Let's try a couple more examples dealing with absolute value equations. This first example, we have the absolute value of 5x plus 7 equals 2. So basically what I'm going to do here is I'm going to take what's inside the absolute value and realize that that quantity needs to either be 2 or negative 2. So we'll take 5x plus 7 equals 2 and 5x plus 7 equals negative 2, because the absolute value of only those two numbers would give me positive 2. Now from there, now I'm going to figure out what x needs to be. So we'll solve each of these linear equations, which is much easier because these guys do not have the absolute value. You cannot try to solve this equation right now from the beginning trying to solve for x if the absolute values are here. You have to get rid of the absolute values first by setting the inside, like I said, equal to 2 and negative 2. All right, so from here we'll solve for x. So I'll do that kind of quickly. First equation, we'll subtract 7 from both sides. 2 minus 7 is negative 5, and we'll divide both sides by 5, and so x will be negative 1. So there's one solution. All right, or let's solve the second one. Again, we'll subtract 7 from both sides. So 5x equals negative 2 minus 7, that makes negative 9. And again, we'll divide both sides by 5. So x equals negative 9/5. It's kind of a weird answer. It's a fraction, but that's okay. You can have fractions as answers. So either of these x's, if you plug it in to the expression on the left-hand side, it'll give you either 2 or negative 2. And then the absolute value of either of those would give you positive 2. And so that makes both of these solutions to this equation here. All right, let's try one more. All right, this one here, we have negative 3 times the absolute value of x minus 1 plus 2 equals 2. All right, now I made a comment in the previous video that you can't set anything equal to like 2 and negative 2 or those sorts of things until this absolute value expression is isolated all by itself on one side of the equal sign. So that's the first thing I have to do. And while I'm at it, let me go ahead and make another comment as well. This is a very common mistake I see a lot of students make. A lot of students want to distribute coefficients like this through absolute values, almost like the absolute values were kind of like a parentheses. You cannot do that. That doesn't make any sense. You can't say negative 3x plus 3 or anything like that. Absolute values basically lock down, like in our case, the x minus 1, and nothing can be distributed through those guys. So let me try to isolate this guy. So step 1, I'll subtract 2 to the right hand side. We'll get negative 3 absolute value x minus 1 equals 2 minus 2. We'll subtract 2 from both sides, so we get 0. And then the next step, we'll divide by negative 3. And so we'll get the absolute value of x minus 1 equals 0 divided by negative 3, which is 0. And so now I have the absolute value expression isolated. Okay, so you have to have this guy isolated before you do anything else. Now this is kind of a peculiar example. Normally we have the absolute value of x minus 1 or whatever it is equal to a number like 4 or 6 or 2 or something like that. But here it's equal to 0. So I mean, I suppose you could keep in line with what we've been doing. You could say x minus 1 equals positive 0 or negative 0, but that doesn't make sense. Positive 0 or negative 0, those are both 0. And so I only actually need one equation for this example. Normally you need 2, but in this example just one's sufficient because it's just equal to 0. And then we'll solve this and we'll get x equals 1. So the only x value that'll make x minus 1 equals 0 is 1. And the absolute value of 0 is 0, and we're done. So again, the thing I want to reiterate about this example is that you have to isolate the absolute value first before you do anything. And then if you have it equal to 0, well, the only way that would have a solution is if just the inside equals 0, period.